Okay, welcome America, welcome Tay-Tay. We hope that you enjoy this video on the exterior angle theorem. Those buses are loud, aren't they? Beep, 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 beep. Okay, so we are on slide number 7. Let's try that again. All right, and we've got, the question says, use the exterior angle theorem to find the measure of angle 2, and then check your answer. So I want to show you why the exterior angle works, this theorem works the way it does, okay? So you don't have to do this every time, but just you have an idea about where it's coming from. So we know that the sum of all 3 interior angles in any triangle adds up to 180, right? We're given 2. What's the missing one? You guys have calculators. What is it? I'm recording. Somebody, come on. 75, 64. What's the missing one?
41.
41. Can I get a confirmation that that's 41 degrees from somebody else?
It is.
41 degrees it is. Now, we also know that this is a straight line. So the sum of those 2 angles is 180. So what's the measure of angle 2? Together they make a straight line. 139. So the measure of angle 2 is 139. What the exterior angle theorem says is, we don't have to go through all this, okay? We know that since these 3 angles add up to 180, and these 2 add up to 180, that the measure of this exterior angle, angle 2, is the same as the sum of these 2 angles on the other side that are not in a linear pair with that angle. So all you have to do, rather than going through this whole process, is add 75 and 64. What's 75 and 64 when you add it together? It should be 139.
Yeah.
There you go, 139, done. So rather than figuring out the 41 and then subtracting it from 180, you can just add the 75 and 64. So that is it. So the measure of angle 2 is 139 degrees. Done. Questions? That's the exterior angle theorem. Everyone always forgets this later on in the year. So now I've got a video to document it. You can watch it anytime you want. Anytime you want. Why are we wearing purple again today? What's the day today? What is it?
I don't think we need to be.
Well, they said this for, they told us to wear purple today.
Okay.
For something.
I forgot.
I forgot too, but I wore it. We have so many days. All right, so the next thing we're gonna look at is, we're going to talk about congruent figures and congruent triangles, really. So I've got 2 figures up here that all the sides are the same lengths, but look at the figures. Are they congruent? Are they the same shape and the same size?
No.
I mean, could you cut this one out of a piece of paper and superimpose it onto this one and it be exactly the same? No, they're not congruent. So just because the lengths of the sides are the same, doesn't make the figures the same, okay? And then, same with the angles. Kind of move this triangle around, I'm gonna make it bigger. You can see that the lengths of the sides are different here because they're bigger. This triangle is bigger than this one. But notice they fixed the angles. So the measure of this angle is 81 degrees. The measure of this angle is 44 degrees. The measure of this angle is 55 degrees. So, just because all the angles, all the corresponding sets of angles are congruent, also doesn't make the 2 triangles the same shape and the same size. Doesn't also make, you need both. You need to have all the corresponding sides be congruent, and you need all the corresponding angles to be congruent. So the last thing I'm going to show you is congruent statements. So the congruent statement we have here, and this is the important part right at the top here. Triangle ABC is congruent to, and congruent sign is an equal sign with a little squiggly. Triangle GHJ. This tells you a lot of information. This tells you that A corresponds to G, and B corresponds to H, and C corresponds to J. So when we're writing out the congruent sides in angles, we don't actually even have to look at this diagram, which is kind of confusing because they flipped it around. This side corresponds to this side over here. So AB, side AB corresponds to, see how it's the first two letters in this triangle? Corresponds to GH. So you just type in, I don't know if I can type that in. GH. Otherwise, you have to look at the diagram and say, all right, is it HG, is it GH? Which direction am I going? This has been flipped around. It gets a little confusing. So let's go to the next one, BC. BC are the second two letters in the name of this triangle, BC. BC corresponds to HJ. And then AC corresponds to GJ. Any questions about the congruent sides? I'm only at 6 minutes, so I'm doing pretty well. Now let's go to the congruent angles. We can use the same congruent statement that tells us the two triangles are congruent. A corresponds to G, B corresponds to H, C corresponds to J, and we put them in. So what did I just say? A corresponds to G, B corresponds to H, and C corresponds to J. Any questions on that? Alrighty then, am I going too fast? Now, how we name the triangle is important. The first triangle, okay? So this one they gave us a congruent statement, FDE, FDE, and that's congruent to triangle MLK. What's important here is they chose to name the first triangle FDE. So we have to name the second triangle the exact same direction. But let's say they want to name the left triangle DEF. DEF. How are we going to name the other triangle? We have to name it the same direction. So DEF, LKM. Second triangle has to be LKM. Are you with me? Let's say they named the first triangle a different way. They named it FED. Perfectly fine. But then we have to name the second one MKL. And the last one, EDF KLM. How are we doing? I think my video is done. Yes. All right. Peace out. Thanks for coming out, Tay Tay.